Now let's see how to plot VTC characteristics of CMOS inverter. For that, type Vim day 3 VTC characteristics. We look into spice file. Here we are again considering lib.spice, and we are doing it in typical corner. And for CMOS, we are including both NFET and PFET. With W for PFET, we are sizing the W width of 0.84 micron, whereas for NFET, we are taking width of 0.36 micron. So if we take W by L ratio of PFET to NFET, it will be around 2.33, and we are taking load of 50 femtofarads, and we are sweeping DC. We are sweeping the input voltage with from 0 to 1.8 with step of 0.01. Now let's run it. For that, type ngSpice, file name. Here type plot out versus in. If you can see, this is the VTC characteristics for CMOS inverter. Now to plot switching threshold for this, we have to switching threshold is somewhere where V in equal to V out. If you see, the common area of this curve for V in and V out is somewhere around 0.8 to 0.9. Here it is 0.8 to 0.1 V out here. So this area is the common area. So switching threshold will be somewhere around 0.8 to 0.9. So now let's zoom in. To zoom in, just press right mouse button and hold it. If you now see, it will be somewhere around 0.87 to 0.88, so above 0.9. So it will be somewhere around this area. Again, zoom in further. If we look it now, it will be around here. Yes, 0.87 to 0.8 and 0.876 to 877. So it will be somewhere around here. So now let's see. Just click here and see. Yeah, so switching threshold is somewhere around 0.876. For W by L ratio of 2.3, it is somewhere around 0.876. Now this is how you plot switching threshold. Now let's exit this. Now let's see for transient analysis. For that, let's look into spice file. Now for transient analysis also, we are doing in typical corner, and PFET and NFET W by L ratio to be same, around 2.33. And here for transient analysis, we are giving pulse from 0 to 1.8 volts with a shift of 0, and rise time and fall time are around 0.1 nanoseconds with pulse width of 2 nanoseconds and with total time period of 4 nanoseconds. Now we are since we are doing transient analysis, we are taking dot run, and now let's run this and see what we'll observe. For that, type ngSpice and the file name, and now here type plot out versus time in, since we are taking with respect to time. So now here, if you observe, this is since now for rise, to calculate rise delay and fall delay, we have to consider the 50% of VDD. So 1.8 by 2, it will be around it is around 0.9. So it will be around here. So here, this is the output curve. So since it is rising, for rise delay, we have to consider this area. So let's consider this area. So at zero point 0.9, here it is 0.9. Now out minus in. So let's click here and here. Now if you can see, this is 2.482 minus 2.15. It will be around, let's see, 2.482 minus 2.15. It will be around 0.332. Rise delay will be around. So now let's see fall delay. For fall delay, since output is falling, so here we have to consider fall delay. So around this area. Now we take at 0.9. So click here, and for input it is here. Just click here, and if we see it is around 4.3349 minus 4.049. So 4.3349 minus 4.049. So fall delay will be around 0.285. So this is how we calculate rise delay and fall delay in transient analysis. That's it. Now you can continue with day 3 MCQs.